In this video, we're going to continue to take a look at the transformation of trigonometric functions, and we're going to focus on the cosine curve and the tangent curve in this video. I'm not really going to do a whole lot with secant, cosecant, and cotangent because, quite honestly, more times than not, you're going to be using either sine, cosine, or tangent. So you probably need to be more familiar with those three. So let's go ahead and take a look at the first one. The transformations that you're doing are the same as we've looked at before, changing your amplitude, your period, your phase shift, and possibly a vertical translation. And it all depends upon the location of the number within the problem. So the first thing we want to do is look across through here and identify A, B, C, and D. A, remember, is the number that's usually hanging out front. So in this case, A is 4. B is the number that's inside the parentheses in front of the X, which is 2. C is the constant inside the parentheses, and in this case is pi. And then D is the number that most often is tagged at the end, which again in this case is a positive 1. If you recall from our previous discussions, the amplitude is the absolute value of A. So that's going to be the absolute value of 4 or 4. So instead of the cosine curve kind of maxing out at 1, now we're going to stretch it so that it now maxes out at 4. The formula for calculating the period change for the cosine curve is 2 pi divided by b. So in this case, that would be 2 pi divided by 2, which is pi, which means it's only going to take us pi units to see the entire curve. I'm going to skip down to the vertical translation, which corresponds to D. It's a plus, so we're going to go up 1 unit. With the phase shift, again, the easiest thing to do is to think, okay, 2x minus pi equals 0. And then we're going to solve that for x. So I'm going to add pi to either side. So I have 2x equals pi, divide by 2 on either side of the equal sign. So x is pi halves. Since it's positive, that tells me that I'm going to shift right pi halves units. Then to determine what I need to use to find my other points, we know that that point, pi halves, is my starting point. Okay, so then we need to find the second point, the third point, the fourth point, and then our ending point. Okay, and to do that, we use the period divided by 4. That's the increments. That's how we're counting. And so our period here is pi over 4. So for the second point, I would have pi halves plus pi fourths, which is 3 pi fourths. Then I have 3 pi fourths plus pi fourths. That's 4 pi fourths, or simply pi. Then I have pi plus pi fourths, which is 1 1/4, or 5 fourths. 5 pi fourths. Then I have 5 pi fourths plus pi fourths is 6 pi fourths, or simplified is 3 pi halves. Okay, so on my graph, I'm going to need to use the values pi halves, 3 pi fourths, pi, 5 pi fourths, and 3 pi halves. Now again, I want to try to show you the original basic cosine curve on the graph so you can see how these numbers and things have affected it. Okay, so on the next slide, I'm going to sketch for you initially the very basic cosine curve. Okay, so I'm going to draw my vertical axis and my horizontal axis. Remember, horizontal is x, vertical is y. 1, 2, 3, 4, 5. 1, 2, run out of space. Let me see if I can make it just a little bit longer. -3, okay? Then initially on the basic cosine curve, we use the quadrantial angle. So we'd have 0, pi halves, pi, 3 pi halves, and 2 pi. We could also rotate that negatively and have negative pi halves, negative pi, negative 3 pi halves, and negative 2 pi. So if you're thinking about the basic cosine curve, the basic cosine curve begins at 1, it ends at 1, halfway it's at -1, and then you have zeros in between. So if you think about it as a pattern, you have 1, 0, -1, 0, 1, so that you have this basic shape of the cosine curve. If I go backwards or rotate negatively, again, you still begin at 1, you're still going to end at 1, you're going to mid at -1, and you're going to have zeros in between. Okay, so there's 2 cycles of a basic cosine curve. Now, for the graph that we want to create, let me back up for just a minute so you can see it. We want to change the period to pi. So instead of taking 2 pi to see it, we're going to shrink it so that it only takes pi units. We're going to also shift it right pi halves, up 1, and change the amplitude to 4. Okay, so let's see if we can do all that. All right, first, I'll need to get my points on the line, and we figured those. Okay, so we said that we're going to shift pi halves to the right. Okay, so my beginning point is going to be at pi halves. Then we added pi fourths and we got 3 pi fourths. Then pi, then 5 pi fourths, and then 3 pi fourths. If we want a second cycle, we could continue going in the positive direction, or I could go back in the negative direction by subtracting. I would have pi fourths, 0, negative pi fourths, and then negative pi halves. And that's going to give me the two cycles that I need. Okay, so I've got my numbers there. Then we want to shift it up 1. We're going up 1. So now my imaginary 0 line, if you want to picture it that way, and that's the easiest way to do that, is to picture it as your new 0 line is now going to be at +1. Okay, and we have an amplitude of 4, so we have to be 4 units above that 0 line. So normally our beginning point was pi halves, and normally cosine begins at a value of 1, but when you shift it up 4, you got to be 4 units. 1, 2, 3, 4. So you're going to begin and end at that point. Midway, normally you would be at -1, okay, from below the line. So then we're going to shift it. But it's got to have a height of 4, so you want to be 4 below. 1, 2, 3, 4. And then you're going to be on the 0, which is actually 1 when you shift it up 1. So you get basically this curve right here. Sorry, it's a little crooked. But again, let me kind of show you here. Again, when you're thinking about the amplitude, you're measuring the amplitude from that imaginary 0 line to the low point or to the high point. So again, this should have a value of 4. Okay, so if I do that again, let me go back over here. Again, we begin at our high point, which is, in this case, 5. We're going to end at 5. We're going to mid at our low point, which is -3. Okay, and then we're going to be at zeros in between. And so you get this curve. Again, if I maybe can draw it a little bit better for you. Okay, so the purple there is our curve. Y equals 4 times the cosine of 2x minus pi plus 1. You got a lot of things going on there at once. Okay, if you'll learn the patterns that go with the different graphs, it's going to help you when you're trying to create that particular graph. All right, let's take a look at another one. I've added one little extra twist to this particular problem. This particular one also includes a reflection. We haven't really looked at one of those previously in the examples, so I've added that. So again, I'm going to begin by identifying A, B, and C. A here is -1/2. B is 3. C is pi halves. And D is -2. So again, my amplitude is the absolute value of A. So I have the absolute value of -1/2, which is +1/2, because that negative is important. You can't just ignore it because you want to. The fact that that's negative, that tells me that I'm going to have a reflection over the x-axis. Okay, so that's like you're going to flip it this way. You're going to flip it around the x-axis, sort of like a water wheel or Ferris wheel. Okay, then if we continue on, let's see, our period for cosine is 2 pi. So we'd have 2 pi divided by b. So that's 2 pi thirds. Not a very nice number, but that's what it's going to be. My vertical translation is going to move me down 2 units. And then let's see if we can do some work on our phase shift. So we would have 3x plus pi halves equals 0. I'm going to subtract pi halves from either side. So I have 3x equals negative pi halves. Divide by 3. Divide by 3. Remember your fraction rule. Flip and multiply. So this becomes negative pi sixth. So because it's negative, that tells me I'm going to go left, and I'm going to move left pi sixth units. Okay, so let's see if we can find, that's our starting point, remember, is x equals negative pi sixth. Okay, to find our increment, we've got to do the period, which is 2 pi thirds divided by 4. Again, remember, you got to flip and multiply, so that becomes 2 pi thirds times 1/4, which is 2 pi over 12, or simplifies to pi sixth. So we're going to be counting by pi sixth as we think about creating the points for our graph. Okay, so my second point would be pi sixth, or negative pi sixth plus pi sixth, which is 0. My third point would be 0 plus pi sixth, which is pi sixth. My fourth point would be pi sixth plus pi sixth, which is 2 pi sixth, or pi thirds. And then my ending point is going to be 2 pi sixth, or pi thirds, plus pi sixth, which is 3 pi sixth, or pi halves. So the values that I want to put on my horizontal axis are going to be negative pi sixth, 0, pi sixth, pi thirds, and pi halves. Okay, I'm going to try to only graph this particular curve so that hopefully you can just see that one curve on the graph and see how it changes instead of trying to graph both of them. Okay, so here we go. We got to draw our vertical axis, which is the y, and we got to draw the horizontal axis, which is our x. Okay, on the vertical, we usually number 1, 2, 3, 4, 5. Okay, in this case, we're going to start at negative pi sixth. Then we have 0. Then we have pi sixth. Then we had, what was it? Pi thirds. And then pi halves. Okay, so that's going to give us one cycle. If you want to continue on, you can continue adding 6. Then we would have 2 pi thirds. We would have 5 pi sixth. We would have pi, and then we would have 7 pi sixth. That's going to give you 2 curves. Okay, we've got to shift it down 2. So again, you've got to imagine that your 0 line is now at negative 2. Okay, so that's like your imaginary 0 line. Typically, your cosine curve begins at its maximum, which is 1, okay? But we need to change the amplitude from 1 to 1/2, and we've got to reflect it. So instead of going up, we have to go down a half unit. Okay, so that's going to be my beginning and my ending point. Typically, my middle point, we would be at 1 unit below the 0 line. We're changing that to a half and reflecting it. So now it's going to be above, and you have zeros in between. So we begin at our low point, which is 1/2 unit below the 0 line. We end at that same point. Halfway, we're halfway above, and we have zeros in between. So this would give you 2 cycles of the curve y equals negative 1/2 times the cosine of 3x plus pi halves minus 2. Okay? All right, let's move on to tangent. Now, a couple of things about tangent. When you start thinking about your period, the period of tangent is only pi units. Okay? We don't have to have we don't have to go a full revolution around the unit circle. But we can still identify initially A, B, and C. So we have A is 2. B is the number in front of the x, which is an understood 1. C is the constant inside with the x, which in this case is pi sixth. And D is the number tagged at the end, which is plus 1. Okay, so that plus 1 tagged at the end, the D, tells us our vertical translation. So we want to shift the entire graph up 1 unit. We still find the amplitude as the absolute value of A. So the absolute value of 2 is 2. Here's where you have the change. The formula for calculating the period for the tangent is 1 pi over b. So I'm going to have pi divided by 1, which in this case is pi. I don't really have a period change here. The other change is, and hopefully you remember this from the discussion earlier of the tangent curve, but we normally start the tangent curve at negative pi halves. We normally look at what happens between negative pi halves to positive pi halves rather than starting at 0 because of the way the curve is shaped. And so one of the things that we do is now I'm going to say x minus pi sixth is equal to negative pi halves to help me find where those values are that I need for starting the curve, or to find my phase. Well, really to find the phase shift, we should do C over B. So to find the phase shift, let me back up. To find the phase shift, we are going to set it equal to 0. Okay, to find the phase shift. All right, and then we'll think about finding the starting point. So we're going to set this equal to 0. So we add pi sixth. We add pi sixth. So x equals pi sixth. Since it's positive, that tells me I'm going to move it to the right, pi sixth. And so I want to find out what that point would be on my number line. Well, normally we begin the tangent curve with an asymptote, okay, at negative pi halves. So if I got to shift that pi sixth to the right, we're going to say x minus pi sixth equals negative pi halves. Okay, and I'm going to solve that for x to find that starting point. So we say plus pi sixth plus pi sixth. Now remember, you got to have a common denominator here. Pi halves would be negative 3 pi sixths plus 1 pi sixth is negative 2 pi sixths or negative pi thirds. So in this case, it's a little bit different. My start point is different, but my start point is going to be negative pi thirds. I still can use the idea that the increment is period, which in this case is pi divided by 4. So to get my second point that I need to mark on my grid, I've got to do negative pi thirds plus pi fourths. Now you're going to have to find a common denominator, okay, which is 12. So we would have negative 4 pi twelfths plus 3 pi twelfths, which is negative pi twelfths. To get the next point, we have to do negative pi twelfths plus pi fourths. So that's negative pi twelfths plus 3 pi twelfths, which is 2 pi twelfths or pi sixth. Okay. Then to find the fourth point. Okay. To find that fourth point, we go pi sixth plus pi fourths. So that gives us 2 pi twelfths plus 3 pi twelfths, which is 5 pi twelfths. And then our end point is going to be 5 pi twelfths plus pi fourths, which is 5 pi twelfths plus 3 pi twelfths, or 8 pi 12, which simplifies by 4 pi thirds. thirds. Okay. So the points, this one's a little bit trickier. The points that we're going to use are negative pi thirds, negative pi 12, pi 6, 5 pi 12, and 4 pi thirds. Okay, and again, that gets a little wonky. I do realize that. Okay, so hang on. Let's go over here and try to draw the graph. Okay, on the next page. We start with our coordinate grid. Okay, so we have our vertical scale. And our horizontal scale. Okay, on our vertical scale, we're going to start at negative pi 6. Then we're going to go to negative pi 12. Then we go to, what was the next one? I forgot. The third point is pi 6. Okay. So I have pi 6 and 5 pi 12 and 4 pi thirds. Okay, so we have, oops. Pi 6, 5 pi 12, and 4 pi thirds. Is that it? I'm sorry. It's hard to keep up. Negative pi thirds. Okay, I got the wrong one in there. Then negative pi 12, pi 6, 5 pi 12, and 4 pi thirds. Okay, so my first point here is incorrect. I'm sorry about that. So let's see. 4 pi thirds goes here. And then let me correct my error. Okay, my starting point here should be, whoops, let me just start all over because I got it all messed up. Okay, start over. Sometimes you have to do that, guys. So we're going to draw the vertical axis. That's the Y. Then we have the horizontal, which is the X. And so we're going to start at negative pi thirds. Then we go to pi 12, negative. Then we go to pi 6. Then we go 5 pi 12 and 4 pi thirds. Okay. Then we want to take it and shift it up 1. Okay. So normally we would start at the 0 line, but because we want to take it up 1, okay, we need to imagine that the 0 line is now up 1. And the other thing that we're going to do as we draw this curve is we're going to change the amplitude, and the amplitude is going to change to 2. Okay, so typically the tangent curve begins with a vertical asymptote. It ends with a vertical asymptote. At the halfway point, you would be at 0, but we have to shift that up 1. So we're going to be at 1. Then on the left side, you would normally be 1 unit below the 0 line, but we're going to change that to 2. Okay. And then on the right side, you would normally be 1 unit above the 0 line, but we're changing it to a height of 2. Okay, so right here. Okay, and so the curve looks something like this. And there you go. Okay, that's the tangent curve. Okay, that's the graph of y equals 2 tangent of x minus pi 6 plus 1. It's a little bit trickier. Let's try one more. Okay, so we have y equals negative 3 times the tangent of 1/2 x plus pi minus 2. So again, we begin as we always do, and we identify all of our pieces. So in this case, I have A is negative 3. B, the number in front of the x, is positive 1/2. C is pi, and D is negative 2. So first off, the D, which is negative 2, tells me I want to shift the entire graph down 2 units. My amplitude is still the absolute value of A, so the absolute value of negative 3 is 3. But remember, that negative is important, guys, because that negative tells me, again, there's going to be a reflection over the x-axis. Okay, so that's going to be important to remember when I start to graph this particular equation. My period here would be pi divided by b. So I have pi divided by 1/2. Okay, remember when you're doing the division, you're going to flip and multiply. So pi, oops, sorry about that, jumped on me. Okay, so I'm going to scratch that over here. I would have pi divided by over 1 times 2 over 1. Remember, you got to flip and multiply, so that becomes 2 pi. So my period actually gets longer, which means I'm stretching the curve. My period is 2 pi. To determine the phase shift, we do 1/2 x plus pi equal to 0. So I have subtract pi from either side. 1/2 x equals negative pi. Then I'm going to multiply both sides by 2 to get rid of the fraction. So x equals negative 2 pi. Okay, so the fact that it's negative 2 pi tells me that I'm going to shift it left 2 pi. But remember, with the tangent, there's an extra step because that doesn't really give me my initial starting value. To find that initial starting value, I have to take 1/2 x plus pi equal to negative pi halves. There's a couple of things we could do here. If you don't like the fractions, we could multiply 3 by 2. So I'm going to do that. So I have 1x plus 2 pi equals negative pi. Then I'm going to subtract 2 pi, so that I have x equals negative 3 pi. So my start point, in order to accommodate my phase shift, is going to be at negative 3 pi. Then I take my period, which is 2 pi, divided by 4, which is pi halves. So to find the other points, we're going to add pi halves. So my second point is going to be negative 3 pi plus pi halves, which is going to be negative 2.5 or negative 5 pi halves. My third point would be negative 5 pi halves plus 1 pi halves. That's negative 4 pi halves, or negative 2 pi. My fourth point would be negative 2 pi plus pi halves, which is negative 3 pi halves. And my end point would be negative 3 pi halves plus pi halves is negative 2 pi halves, or negative pi. Okay? So again, those numbers are really kind of strange, but it's because we don't typically start the cosine or the tangent curve at 0. So we have negative 3 pi, negative 5 pi halves, negative 2 pi, negative 3 pi halves, and negative pi. All right, so let me see if I can help you draw this. Okay, here we go. All right, so we have our vertical axis. And 1, 2, 3, 4, 5. Okay, these are ones. Then you have negative 1, negative 2, negative 3. All right, we're going to start on the left, and we're going to start at negative 3 pi. Then we go to negative 5 pi halves. Maybe I better put those closer together to get them all in here. Hold on. Okay. Negative 5 pi halves. Negative 2 pi. Negative 3 pi halves. And negative pi. And I could continue with that. I could go negative 2 over 2. Negative pi halves. I'm off a little bit, I guess. And then 0. Sorry. All right, so let me see if I can adjust this just a little bit for us so that it makes sense. Whoops. My eraser didn't kick in. Okay, so I'm going to start at counting at 0, so see if that'll work better for us, I guess. Should always start at 0. Okay, so we have our horizontal axis. And that's our x. Okay, so we have 0, then we have negative pi halves. We have negative pi, negative 3 pi halves, negative 2 pi, negative 5 pi halves, negative 3 pi. We could also keep going in the positive direction and have pi halves, pi, 3 pi halves, and 2 pi. Okay. We need to shift it down 2. So again, you're going to have to imagine that your, sorry about that, that your 0 line is now at negative 2. So I'm going to kind of dot that in. So my 0 line is now at negative 2. With the tangent curve, we normally start and end at an asymptote. So my starting point was at negative 3 pi. My ending point was at negative pi. And a second ending point would be at pi. Okay, at the halfway point, we're normally at 0, but we have to shift down 2. And then I have to change the amplitude to 3, but I also have to reflect it. So normally on the left, we would go down 3. But because we are reflecting it, I've got to go up 3 from the 0 line. So 1, 2, 3. And then on the right side, we're going to go down 3. 1, 2, kind of get off the screen there. Have to kind of fudge it a little bit. So you have kind of this curve right here going on. Again, if we do it again, you begin with an asymptote at the beginning. You end with an asymptote. Halfway, you're at the 0. And then we're reflecting and changing the amplitude by 3. So we get something that looks like that. Okay? So hopefully you'll find that helpful. We did at least look at what happens if you do a reflection. You've seen the 3 basic curves, sine, cosine, and tangent.